to motivate the need for dynamic management of data and metadata, it's useful to look at the structure of a traditional NFS server, which is centralized. In a traditional centralized NFS server, what you have is the data blocks are residing on the disks. So in the memory of the server, the contents include the metadata for the files, like the inode structures, and file cache, which is files that have been brought in from the disk are stored in the memory in what is called the file cache, so that future requests for the same files can be served from the memory of the server rather than going to the disk. And the server also keeps the client caching directory, that is, who on the local area network are currently accessing files that is the propriety of this particular server. And in a Unix file system, the server is unconcerned about the semantics of file sharing. Or in other words, the assumption is that the server is caching for each client completely independently. And therefore, if clients happen to share a file, that is completely the problem of the clients, and the server is not concerned about that. So all of these contents that I just described to you, metadata, file cache, client caching directory, all of these are in the memory of a particular server. And if this server happens to be housing hot files used by a lot of users that is being served by this particular server, then that's bad news for the server in terms of scalability, because it has to worry about the requests simultaneously coming from lots of clients for these hot files, and so it is constrained by the bandwidth that's available to access the files from the disk. It is constrained by the amount of memory space it's got for caching files and the metadata of the files and so on. At the same time, there could be another server that also has adequate bandwidth to the storage and memory space, but unfortunately, it may be housing cold files, and therefore, there are not many clients for this server. So you can immediately see that this sort of centralization with the traditional file system results in hotspots. And that's the thing that we're trying to avoid in a distributed file system, and that's where dynamic management comes into play. So in XFS, it provides the same functionality as a centralized NFS server, but it is distributed and the metadata management is dynamic. And that is, in a centralized file server, the mapping between the manager node for a file and the location of the file is the same. Or in other words, if the file happens to reside on the disk of this server, then this server is the guy that is going to handle the metadata management for this file as well. On the other hand, in XFS, metadata management is dynamically distributed. So let's say that you have F1, F2, and F3 are the hot files. In that case, metadata management for files F2 and F3 can be done by some other node, say S3, and this server may have the cache for the file. So in other words, all the data structures that we talked about that has to reside in the memory of a particular server, like metadata, file cache, and the caching information about who's having the files and so on, all of that can be distributed with dynamic management of data and metadata, which is the idea in XFS. And I'll shortly explain how exactly this dynamic management is facilitated by the implementation of XFS. So in any systems research, there is always first the idea, and then there is the implementation. So the idea in XFS is that we want to manage the data and metadata management dynamically, and we'll see how that is done. And also, what we want to do is we don't want the cache for the files to be only at the server. What we would like to be able to do is, if a file is accessed by several different nodes, then they are living in the client caches of the different nodes. If a file is residing in the cache of a peer node, then it makes sense that if a new request comes for the same file, then getting that file from a peer cache may be much more efficient than getting it from the disk. And that way, we can also conserve the total amount of memory that's available in the servers and use it more frugally by exploiting the memories that are available in the clients, so that the caching of the files can be done cooperatively among the clients. And that's the other nugget in the technical contribution of XFS is the cooperative client caching.